Hello everyone, I'm İpek kkaya. I'm an undergraduate student at Bilkent University in the physics department. I will be showing you the footage of the experiment that I conducted in the lab for the course of modern physics. Our experiment is about observing discrete energy levels by measuring the emission lines of various chemical flames using spectrometer. A photon is an electromagnetic radiation with a discrete energy, given by Planck's constant times frequency, that is emitted when an excited electron returns its lower energy state. Since the emission takes place at certain frequencies, a spectrometer will split the wavelengths of the light that corresponds to those frequencies and show them as sharp emission lines. In the experiment, these peaks were observed with the corresponding wavelengths. We painted a shoebox black inside and covered it with carbon paper. We did this in order to close the gaps and make the inside completely dark. We opened a long and narrow slit with a cardboard box cutter, and we stuck two razors to the slit with tacket in order to make the slit even narrower. We fixed a diffraction grating to a tiny plastic platform with a tacket and angled approximately 30 degrees. We positioned it directly along the slit to maximize the light intake. After the alignment, we connected the webcam's USB port to the laptop and opened the software Theramino. After connecting the webcam to Theramino, we tested the alignment by observing a full spectrum through the Theramino software. We accomplished this by holding a flashlight to the spectrometer. We also did calibration. We used two lasers. We had one green laser to the spectrometer and observed a green peak in the Theramino software. We assigned this value of the wavelength 531 nanometers. Then we held a laser of 640 nanometers to the spectrometer. In Theramino software, we assigned this wavelength value as 640 nanometers. We constructed the experimental setup by aligning a Bunsen burner and the spectrometer in a straight line. We closed each curtain in the lab. To level the Bunsen fire with the spectrometer slit, we used a magnetic stirrer and a wooden piece from the chemistry lab. We prepared salts for sodium, lithium, copper, and barium. One of the team members held a black cardboard behind the flame to block any extra light. We fixed the black cardboard to the table as a safety measure. We took measurements by applying the flame test of every salt 5 times with the titanium stick. For sodium, we observed a sharp peak around 586 nanometers. This is in accordance with the literature value of 589 nanometers. For lithium, we observed a sharp peak around 653 nanometers. This is in accordance with the literature value of 670 nanometers. For copper, we observed a sharp peak around 545 nanometers. This is in accordance with the literature value of 521 nanometers. For barium, the most intense peak was at 550 nanometers, which is in accordance with the literature value of 551 nanometers. Here, you can see the flame color for sodium, for copper, for lithium, for barium. The percentage error for each salt can be seen in the table. The errors are due to non-perfect blocking of light, titanium wire heating up, and impurities in the samples, which cause noise in the signal. We can use a better camera, diffraction grating, and do more precise calibration to enhance measurement accuracy. To reduce the noise, we can make the walls of the box thicker, use a diffuser tape in front of the slit, or use an optical fiber for the slit. Overall, we demonstrated the quantum phenomenon of discrete energy successfully with high accuracy by constructing a spectrometer.